my dear students. Today we are going to learn the relation between parallel and perpendicular lines through their slopes. First thing is parallel lines. If we have two parallel lines like these two purple and green lines, the slope of two parallel lines are the same. Slope of each parallel lines are the same. So if the purple line have slope 3 over 5, the green line will also have the same slope 3 over 5. And if we have two perpendicular lines like the purple one here with slope 7 over 6, what will be the slope of the green line? We will get the slope by flipping the number and putting the opposite sign. Okay, so if it is positive 7 over 6, the green line will be negative 6 over 7. Okay, so let us have some examples here for slopes or of parallel lines. If we have parallel lines, if we have two parallel lines, okay, the slope of the first one equals 5. This means that the slope of the second one is the same 5. Why? If we have two perpendicular lines like this, they make 90 degrees together, two perpendicular lines, where M1, for example, is 1 over 2. What will be the slope of the second line? It will be, we will flip 1 over 2 to make it 2 over 1, or just 2, and we will put the opposite sign. Here it is positive, so it will be negative. Another example for perpendicular lines, if M1 equals negative 1 over 7. So what will be M2, or the slope of the second line? It will be positive 7 over 1, or just 7. And if, for example, it is 5, this will be M2 will be equal, we will flip the 5 to make it 1 over 5, and we'll put the opposite sign, negative. So I hope you understand this, the slopes between parallel and perpendicular lines. Let's have the first example here about having, if we have two lines that are parallel, it says that they are parallel lines. And we have parallel lines, they have the same slope, remember this. Okay, let's read the question. It says write an equation in slope-intercept form for the line that passes through negative 4 and 2 and is parallel to another line whose graph has the equation y equals 3x minus 5. So for example, if the first line has the equation 3x minus 5, this line, and I'm looking for the equation of the second line which is parallel to it, and I wanted to write it into slope-intercept form. The first thing to have, I must have the slope. Okay, so the slope, how can I get the slope of the second line that passes through the point negative 4 and 2? The slope, I will get it from the first equation or the first line because they are parallel, and I have here, this is the slope-intercept form of the first line, and of course from this equation I will find the slope, which is 3, and the slope of the second line will have the same, or will be the same, so m of the second line is also 3 because the slope here is 3. Now I got the slope. How can I find the equation in slope-intercept form? Okay, the best thing to do, because I have a point which is the line passing through this point, this means I will start by writing the equation in point slope form, because this is the available thing now. I have a point and I have a slope. I will start by writing it into point slope form. Then after I do this, I will change it into slope-intercept form. So this is my plan in my solution. I will start by writing it into point slope form. And the point slope form, we know that it is y minus y1 equals mx minus x1. Okay, we have m is the slope, I have it. I also have the point which is negative 4 and 2, where from this point I can get x1, that is negative 4, and y1, that is 2. So I'm going to substitute here y minus y1, which is 2, equals m times x minus x1, that is minus -4, makes +4. Now this equation is in point-slope form. I want to translate it into, or transform it into, slope-intercept form. The slope-intercept form has the form y equals mx plus b, where y is only on one side by itself. What remains to do here to make it slope-intercept form is just I'm going to change the place of the 2, or I'm going to move the 2 to the other side, and I'm also going to distribute the 3 here on this bracket. So it will be y minus 2 equals 3x plus 12, and after that I'm going to add 2 to both sides to get rid of the 2 here, and this will give me y equals 3x plus 14, and this is the equation of the line that is parallel to the first line, and this equation is written in point slope form and slope intercept form at the end. One last example here. Determine whether AB and EF are parallel, perpendicular, or neither. To know that AB is parallel to EF or not, I'm going to find the slope of each of them. Okay, so the slope here of AB is y2 minus y1 over x2 minus x1. This is -3 over -4, which is 3 over 4. Now look at EF. The slope of EF is y2 minus y1, which is +3, over x2 minus x1, that is -6. It will be 8 over 6. And 8 over 6, if you simplify both of them by dividing by 2 up and down, it will be 4 over 3. Now look at this slope and look at this slope. 3 over 4 and 4 over 3. They are reciprocals of each other, but they are not opposite signs. So we cannot say that they are perpendicular. And of course, they are not parallel because they are not the same. So it is neither perpendicular or neither parallel nor perpendicular. I hope you understand and you like the video. Please share and see you on the next video. Bye bye.